Okay, on tonight's edition of Homework Help, we're working on what's my solution. So for this problem right here, this first problem, I'm not going to do them all, but I am going to do number 1 and number 3. Okay, these are actually, there's crumbs, I'm eating crackers. This is actually not too hard to do. But what you're going to do is remember today in class, we would learn that there's 2 ways that we can identify a solution to a system. We can either look at where they intersect, or we can look at where they intercept, or we can look at where they, we can plug in the x and y and see if they make the statement true. So we're going to start, since I have 2 graphs here, they're the easiest ones to check. Now, like I told you, I like to be able to really easily see where my solutions are, so I'm going to actually highlight the double shaded area so that I can see it on both of these graphs. Okay, so there's my double shaded area on both of these graphs. And they're not perfect, but they're good enough. Okay? So here's my double shaded areas. They're highlighted, easy to find. So let's look at number 1. I'm looking for the coordinates 6, -9. Wait, I was going to do 1 and 2, sorry. 1 and 2. Okay? So I'm looking for the coordinates 6, -9. So I'm going to go over 6, down 9. That is in the solution set for B. It is right down there in there. Okay, let's look at C. If I go over 6, down 9, that one is also in the solution set. Well, spoiler, there's only 2 for each one. So 1 and 3, this one has 2 answers, and this one has 2 answers, and these 3, 2, 4, and 5, each only have 1. So I'm done on that one. I happen to. Now, if I wanted to check the others, though, I would plug in the x. So I'd plug 6 in for x, and -9 in for y, and see if it made a true statement. Now, earlier today when I was doing this, because I always key it before I work with you, I was only checking the first equation, and then I realized, oh my goodness, no, I got to check them both. So remember, it has to satisfy both inequalities, not just one. Okay, so let's take a look at this one. I'll use the back of a piece of paper so you can see what I'm going to do. So I'm trying to test this to point 0, 4. Okay, so I'm going to go over 0, up 4. Well, I can see that is not in the solution set for B. Over 0, up 4, that is not in the solution set for C. So I got the easy ones out of the way. Now I got to see which ones of these, one or both, it works for. So I'm going to start with the first equation, x plus 2y less than 8. So x is 0, 2y is 4, so 0 plus 2 times 4 is less than 8. Well, 0 is 0. 2 times 4 is 8. Is 8 less than 8? No. 8 is not less than 8. So 0, 4 does not work for the first one. Now, if it worked for the first one, I would still have to check the second one. Okay, so let's try it over here. I know it's not right here because it doesn't make this first inequality true. Let's try over here. So I have 2 times x, which is 0, plus 3 times y, which is 4, should be greater than or equal to -12. Well, 2 times 0 is 0. 3 times 4 is 12. Is 12 greater than or equal to -12? Yes, it is. That alone does not make this inequality true. It has to work for both of them. So it works for the first one. Now I got to try the second one. Well, my ordered pair is 0, 4. So it's y, which is 4, greater than or equal to 3 times x, which is 0, minus 1. 3 times 0 goes away. Is 4 greater than or equal to -1? Well, yes, it is. And so since it worked for both of them, that means D satisfies. So 0, 4 is a solution for D. Okay? So remember, we have 2 ways we can check these. We can either graph them, or we can substitute the coordinate into each equation and see which one works. Okay? I also said that I would do number 7. So let's take a look at number 7. It says to verify one ordered pair by substituting into the box below. I'm not really concerned about that. I'm concerned about you graphing the inequality. If you want to tell me, on this one has this is kind of a special looking answer, so let's take a look at it. Okay, so first of all, I have this 3y less than or equal to 2x minus 12. That is not in slope-intercept form. It's really close though, so I'm going to go ahead and take the next step, and I'm going to actually get it into slope-intercept form. Well, it's already y by itself, but it's 3y. So I'm going to divide both sides by 3. I get y. Now again, I'm on alert right now because I'm dividing by a number. I might have to flip the sign. But since I'm dividing by a positive number, since this number is positive, I don't have to flip the sign, so I'm going to leave it just the way it is. 2/3 x minus 4. All right? Okay, so this equation is 2/3 x minus 4. So like we did earlier, I'm going to write down what I know about this equation. I know the slope is 2/3. Okay, that's the craziest looking 3, but trust me, it's a 3. Now the y-intercept is -4. I know that it has a solid line and that that line is going uphill because it's positive. I also know that I'm shading below because it says less than. Okay, so let's graph this. I have 2/3 x. Well, I start at -4. I rise 2, run 3, rise 2, run 3. I just keep on doing that. And like I keep saying, you know I don't have to do all the dots, but I like it. It makes me happy. Just let me have this. Okay. So I have a solid line, and I'm shading below. Okay. Now, I'm going to look at my second equation. Well, you should already be thinking, 2/3 x minus 1, these have the same slope, so these lines are going to be parallel. Well, here's what I know. I know that my slope is 2/3. My y-intercept is -1. I know that I'm going to shade above and that I have a solid line going up. Okay, so let's get this going. I start at -1, rise 2, run 3, rise 2, run 3. Yep, as I suspected, I have parallel lines. Okay. Okay. Now it says I'm going to shade above. Well, look at this. When I shade above the line, I had some people, by the way, ask me, like, how do you know when to shade above or below? You put your pen on the line. If it says greater than, you draw an arrow pointing up. If it says less than, you draw an arrow pointing down. And then you shade everything where your arrow is pointing. So since my arrow is pointing up, I'm shading there. Now, with this equation, I have no solution because there's no double shaded area. These are parallel lines. They're never going to get any closer to each other. I'm shading above this one, below that one. I'm never going to have a solution. Now, this does not mean that parallel lines always have no solution, because if I'd shaded below on this one and above on the bottom one, then the area between them would have been the solution. Okay? I know I'm...
Interrupt. Should we need Damian Sanchez to come to the front office?
He needs to come to the front office like right now.
Damian Sanchez?
They're not joking. See, they said it twice. Okay, so now... let's look at this next one. I know I didn't say I was going to do number 8, but I lied. I'm going to do number 8. Okay. So let's take a look at this one. Okay. Now you'll figure out pretty quickly why I wanted to do this one. Okay. So let's take a look at it. These are both in standard form, so we're going to convert them into slope-intercept form. 4x minus 3. I don't know why I just circled that. I meant to circle the 8. I'm a ding dong. Is less than 6. Okay, so I want to get y by itself, so I'm going to circle everything, letter, number, and sign. I'm going to subtract 4x from both sides. I get -3y less than -4x plus 6. I'm going to divide everything by -3, and my math senses are going crazy right now. Okay, since I'm dividing by a negative, my sign has to flip, and this is what I do to remind myself. You don't have to do this, but like I'm always like, I have got to point out that I've flipped that sign. This cancels out, leaving me a y. I have 4/3 x minus 2. Hang on a second, it's getting real loud. Let me pause. Okay, sorry about that. All right, so let's take a look now. Now I've got 4x. Okay, so I already finished it. So I have, let's write it down here. I have y greater than 4/3 x minus 2. Okay, now, first of all, I had a sign flip. So that's one thing that's different about this. I'm going to write down what I know. I know that my slope is 4/3. Again, I left that as a fraction because I'm going to be rising and running. I don't want to be going up 1 1/3 over 1. Nobody wants to do that. And if you do, well, go you. Good for you. But I don't want to do that, okay? So B is -2. I have a dashed line, okay, because it doesn't say or equal to, so my line is not solid. It's dotted or dashed. And then I'm shading above. I also know my dashed line is going to be going uphill because this is a positive slope. Okay, so I'm going to start at -2. I'm going to rise 4, run 3, rise 4, run 3, rise 4, run 3, continue back the other way. And when I do my line, I can just leave dots like that, or I can just put like a little dash through each of those so that my boundary line is a little bit more clear, but it's still obviously dashed. Okay? And now I'm shading above. So this is going to be my shaded area. All right? Now let's look at the other one. Okay? The other one is also in standard form. So let's go ahead and convert that one too. We have x minus 2y less than or equal to 6. Okay? So I'm going to get my minus 2y. I want to leave by itself, so I'm going to subtract x from both sides. Now, you know I don't like naked numbers. I don't like them to not have a coefficient. So I'm going to put that 1 in front of there just to kind of help me remember that there's something there. Now I'm sorry, that was less than or equal to. Now I'm going to divide both sides by -2. Okay? And my math senses go crazy. I got to flip that sign. Okay? So I have y greater than or equal to 1/2 x minus 3. Okay? So let's go ahead and write that down. Y greater than or equal to 1/2 x minus 3. Okay? Now, for this one, my slope is 1/2. My y-intercept is -3. I have a solid line, and it's also going uphill because it's got positive slope. And I'm going to shade above. Okay? So let's plot this guy too. So I'm going to start at -3. I'm going to rise 1, run 2. And then I'm going to continue back the other direction. Okay, let me connect my points. Since it's solid, because it's or equal to, I'm going to connect my points. Okay. Okay. Now, I'm going to shade above. Now, since I've already got one direction, I'm going to have my little lines go in the other direction. Now, again, I'm sure you guys have noticed that it just starts to get real crazy. So once again, I like to color in with highlighter. I like to highlight my shaded area. It just makes it easier for me to identify where the solutions live. Okay? See how now my solutions jump out? Now, the thing to remember about this one is since I have a dashed line, that means that I cannot include any points on that line. So if I was looking at this at 3, 2 as a part of the solution set, it's not. Because even though 3, 2 is in the solution is in the solution set for the green, since it's on the line, it's not part of the solution set. It's not part of the solution set for the red system. Okay. The rest of them are pretty straightforward. For 3, 4, and 5, you're just going to have to substitute, and you're just going to have to check them out. And for this one, you'll just have to graph it yourself. Okay.